So when you're working with polynomials, when you're working with something like 3x squared plus 5x plus 7x squared plus 1, when we're going to add these two polynomials together, we do that by looking for like terms. Now I want you to take a moment and remember, what makes two terms like terms? How do we know when they can be combined in a setting like this one on the right? In this setting, two like terms must have the same variables to the same powers. So for example, 3x squared and 7x squared both have variable x to a power of 2. And I can combine these just by adding their coefficients. I have 10 in total of type x squared from 7 plus 3. Now 5x doesn't have any other terms that contain just a single x, and 1, there are no other terms that are just constant. And so I can identify and combine like terms to simplify polynomials. Now we're going to do exactly the same process when we're adding together expressions that have square roots or nth roots in them. If we're going to add them together, we're going to figure out what makes two radical terms alike, and then we're going to combine like terms by combining the coefficients. Now, when you're going to add together two radical equations, the absolute very first thing that you should do is you should simplify every individual term that you're trying to combine. This is all happening after simplification. Now, after simplification, to decide if two radical terms should be like terms, they're only allowed to be different in one position. After simplification, only the coefficients on the outside of the root are allowed to be different. Everything else must be the same. So in other words, these two roots, after being simplified, their index is the same. They have exactly the same index. After being simplified, these two terms have got to have exactly the same quantity under the root. They've got to have exactly the same radicand. And on the outside of the root, they are not allowed to have different variables. They've got to have exactly the same variables to exactly the same powers. Same variables to same powers. Outside the root. So in other words, the quantities outside the root have to be like terms. Quantities outside the root are like terms. Only the numbers on the outside are allowed to be different. And remember, this is all happening after the individual terms have been simplified. So let's consider this big list of pairs of radical terms, and let's decide which ones are like terms and which ones are not. So first example, what do you think? Square root and cube root, are those two terms like terms or not? All right, I'm going to have to say no, and the reasoning is that these two terms have different indices. The indices are different. One has an index of 3 for cube root, and the other one has an index of 2 for the second root. So big problems there. These are not like terms. Now, what about this pairing? What about square root of x and square root of 2x? What do you think? Are these like terms or no? Again, I'm going to have to say no here. And the problem this time is that the two radicands are different. The two quantities under the square root would have to be identical different radicands. These are not identical, so these are not like terms. Okay, but what if I just scooch that 2 from the inside of the root to the outside? And what if I compared root x with 2 times root x? Now the situation has changed because this 2 is now on the outside of the root. I would say yes, these two terms only differ in the number on the outside. Their indices are exactly the same. They're both square roots. Their radicands are exactly the same. They're both roots of x. And on the outside, they both have just numbers, root x and 2 root x. Now, what do you think about this one? Root x and root 9x. Are these like terms or not? Now, I think the temptation is to say that these terms are not like because their radicands are different. And this is a great instinct. But the issue is that this root on the right-hand side hasn't been simplified yet. So if I simplify this by taking the square root of 9 and the square root of x separately, turning the square root of 9 into simply 3, now I can see, in a sense, the true nature of square root of 9x. Square root of 9x in reality is 3 times root x. And so it's exactly the same as root x except for a difference of the number in front. Only the number in front is different. So I would say yes, these are like terms. Only the number in front is different. Now have a look at this example, square root x versus x square root x. Again, I would have to say that these are not like terms. It looks good for a long time. You have the same index of 2, you have the same radicand of x, but the difference now lives on the outside of the root. On the outside of the root, one has nothing outside the root, and one of them has an x outside of the root. And so that's a difference of a variable. It's not just a difference of a number. And so these terms are not like. Quantities outside the root are not like terms. One has an x and one does not.